My name's John Bowers. I'm a software engineer that works on the Twitch and Amazon IBS video stacks. And today I'm going to talk to you about how to create nearly free, nothing's free, right? High quality ABR renditions for UGC or really any platform. It's a talk about how to reduce the cost and improve the quality of your encoded renditions in your ABR ladders. Very briefly, this is nothing super crazy. This is kind of how we do video processing at Twitch today. The important things to notice here are that people usually use something like OBS Studio and they deliver video to us via RTMP. We'll have a cluster of encoding hardware. We'll generate a full ABR rendition and then distribute that to viewers via HLS. There is an alternate sort of path where whatever the viewer or the streamer sends to us, like 1080p 60 actually, and whatever bitrate they choose, that actually just gets transmuxed and delivered via HLS as a single rendition, which is obviously not a very desirable playback experience because there's really no ABR at that point, right? So, so there's some challenges with that approach. First of all, there's a lack of equality here. Not everyone's going to get full encodes, even though we'd like to provide that service to everyone. But as we know, encoding is expensive. And as a UGC platform, Twitch has thousands of contribution feeds active at any time. And some of them have a very low volume of viewership. So resources don't always exist to do full encodes for everybody. We have in the past bought specialized encoding hardware to facilitate all of this live at scale encoding. But if we do that, that causes this kind of hardware lock-in effect where we can't necessarily take advantage of the codecs and codec improvements of next generation hardware because we've got to amortize the cost of that hardware over a long period. What if I told you there was a way to provide full ABR ladders at scale to everyone with cheap commodity hardware? Well, that's what we are introducing with what we've called enhanced broadcasting, which at its heart, it's just the process of having a streamer generate all of their encodes on their system using the excess capacity of the super powerful NVIDIA GPUs or AMD GPUs, whatever GPU they have on their system, to encode all those things and send them to us. And we can do very light processing, just some transmuxing on the back end. And then we are eliminating the need for expensive encoding hardware, that cluster of encoding hardware that I talked about in the second slide. So if we do this, our architecture has to change a little bit. I'm going to talk about 3 places where we made some changes or worked with people to make changes to make this happen. First of all, the contribution from the broadcast software has to change clearly, because if you're doing multiple encodes and having the streamer send us that, the OBS will have to change. The configuration of the encoders has to change, and the delivery protocol is going to have to change. But if we do all this, at that point, you'll notice that there's no more encoding cluster. What you have instead is just basically server-side transmuxing, which is an order of magnitude less, or at least an order of magnitude less complex and costly. So let's talk about each of these things briefly. First of all, most streamers will stream to Twitch using OBS Studio, which is open source software, the OBS project. We've worked with the folks at the OBS project to get over 30 PRs merged into OBS Studio 30.2.0 to enable multitrack encoding from OBS. So what does that experience look like for streamers if they want to take part in this? There's really very few UI changes. It's basically like a 1 checkbox and you're done. So 30 PRs to add 1 checkbox. It was great. But there's actually even less to configure now. Manual encoder configuration's disabled. So you'll come over here, and where you would normally configure your encoder, you'll see it just says Twitch Enhanced Broadcasting is controlling some of your settings. Well, clearly, encoders have to still get configured. But we felt the complexity of configuring, say 5 different encodes would be a barrier to adoption. So we work to add an interface to OBS to call out with system metadata, like GPU details, CPU details, to what we've called a server-side recommendation engine in this graph right here. And then we will return back what we feel is the optimal multitrack encoder configuration for any given system, right? And on the right, you kind of see what that looks like. It's basically JSON, big JSON blob. If you wanted to support multitrack in OBS for a service other than Twitch, you'd have to implement this server-side recommendation engine, a version of it on your own, because there's no UI to encode, multiple encoder configs in OBS currently. The request and response interface is documented in this multi-track integration guide, which you see the link to here. This will also be useful if you want to contribute a multi-track feed to Twitch from something other than OBS. And there are some other existing integrations, but more to do, I'm sure. And that leads us to the third thing. We needed a new delivery protocol because we were using RTMP, right? It's very old. It doesn't support multiple video tracks, which was very important. So we have been working with Slavic and the Overa software organization. He's leading that and getting feedback from a bunch of industry contributors, such as Twitch, of course, Google, Adobe, a bunch of individuals on open source projects. And there's a link to the version 2 of the spec, which we implemented here. It's still in alpha or beta. I'll leave it to him, but it's not released completely yet. But what does it enable? What do we get out of ERTMP? Well, importantly, we get multiple video tracks, which was very important for this feature. We get multiple audio tracks, which we do make use of for some things. We get new codecs. As we know, RTMP was very old and had a very hard-coded set of codecs you could use, and none of the newer, better compression stuff like HEVC or AV1. So we'll be using that soon too. There's new audio codecs. We're not making use of that, but Dolby Digital and things like that are in there. And more, like on Friday, I saw that there was the addition of a nanosecond precision time offset. So that was just very new. And I think this is interesting too. It's pretty easy to adopt if you already use RTMP because there's very little change to the transport layer. So potentially you could use a very little changed version of whatever RTMP, librtmp library for sending and receiving your RTMP packets. So if you want to support RTMP in your tool, you could potentially, I found that sample media files are very useful. I've generated some EFLV samples that go right along with it, and there's a link here. There's a couple of existing utilities, ERTMP toolbox, there's a FFmpeg branch that supports EFLV. So you can see, you can see why Twitch might want to do this, right? But there is because if we got broad adoption, we might say eliminate maybe 90% of our encoding hardware. Let's just say something like that. It's a big win. But there is a creator value proposition too, because, first of all, not everyone was getting encodes, right, before. And so now, we've seen really good adoption with people that didn't have that already. It's just like a no-brainer, right? Click, check, now I've got the same experience. Also, though, even if you had encodes, there is a quality story to be told as well, because we had this hardware lock-in problem. All of our streamers at this point generally have better hardware than we have in our encoding cluster, and everything's there's a removal of generation loss here, because every single rendition is encoded from a lossless source. You couldn't send up lossless and have us re-encode that. That just wouldn't work. So all of our encodes were, from 1080p 8 megabits or something like that. So let's take a look at what the quality difference might look like. So I'm looking at a frame of 720p just because that's generally the first rendition we'll create from whatever the streamer contributes. On the right side is the new enhanced broadcasting workflow. This is they're both 3.6 megabits, but one is the old Intel QuickSync hardware, very old at this point, that we have on our encoding cluster, and on the right's like a newer NVIDIA RTX 3000. And then also, one's encoded from 8.5 megabits and one's encoded from lossless. So let's just zoom in really quick, and you can kind of see like text that was completely illegible before is legible now. It's 720p, it's not amazing. You could juice the bit rate a bit on this if you wanted to improve both of them, but the importance is that these are the same bit rate, and you can see how big of a difference that is. All right, well, that's it. So thanks, guys.